Open up your statistics paper and one of the first things you'll find is a formula sheet. At the start you might be elated. Perhaps you didn't revise, or maybe it acts as a protective buffer if the paper is a nightmare. But at the same time, you should come to realize it's much more than plugging numbers into a formula. If it was that simple, then everyone would be getting grade 9. The truth is, you need to be able to pick out the values that are relevant to the question, and the most important part, rearrange them in certain scenarios. That's going to be the focus of this video. You get given this skew formula. If they say something as simple as find a skew, and they might do, you just find each of the mean, median, and standard deviation. Put it into your calculator and move on. However, what if it comes to this? You're given a value of skew this time and are asked to find a value within the formula, standard deviation for example. This could be where you fall apart, so the aim of the video is to just build confidence. You'll be able to rearrange difficult equations if you stick to the basics and apply the principles consistently. Some teachers don't go through this because it's assumed knowledge, yet this is where students struggle time and time again. The official reference to the specification expects you to be familiar with the use of formulae and substitution and rearrangement of equations, and it might be that you can do some of the simple ones. It's just when you see a more complex equation, you go blank. If you look at the specification, AO1 tests you on your ability to demonstrate knowledge and understanding using appropriate terminology and notation of standard statistical techniques used to collect and represent information and calculate summary statistics and probabilities. The second bullet point is the most important here. For the Excel at least, and mostly AQA, AO1 contributes to around 55% of your marks. I would admit that it's not entirely for calculations, but a hefty chunk is still in this assessment objective. If you're not confident with equations, you'll be missing out on a lot of marks. So without further ado, let's get into it. Let's start at the true basics. I want to clarify that 2 on its own without any signage is simply positive 2. This will make more sense later on, but it's important if you don't see a negative, it's probably a positive. Therefore, minus 2 is equal to negative 2. No explanation needed here. We can carry this further algebraically. X on its own is assumed to be positive x, so x with a minus in front of it would be negative x. Now that's out of the way, let's look at our operations. From this table, we can either add, subtract, divide, or multiply. You'll notice on the right column here, there is an opposite label. You could probably do this yourself, but I'll do it anyway. The opposite of each of them is as follows. For addition, is subtraction. For subtraction, it would be addition. For multiplication, it would be division. And lastly, the opposite of dividing is to multiply. These rules will come in useful when we get to actually rearranging. I'll first present this to you on a surface level. Don't try to overthink it. X plus 2 is equal to 10. In other words, what value represented by x is such that when I add 2 to it, it becomes 10. Pause the video and just think. You should find that the value that would work for this is 8. When you have a value of 8, you add 2 and you get 10. Now what's the better, more algebraic way? This would be a good time to introduce our first rule of rearranging equations. When you do anything, and that means absolutely anything, you apply the same to both sides. The only goal here is to find x. Isolate x, whatever you want to call it, but right now we have 2 that is being added to the x, and we don't want that. So if you have something adding to the x, how can we remove that? If you remember our earlier operations, then we'd have to apply the opposite. If we are adding 2 to x, we need to subtract 2 from x. The idea is that now the left-hand side of the equation just has x on its own. 2 minus 2 gives us 0, leaving us with the x that we wanted. Now since we subtracted 2 from x, we'd have to subtract 2 from 10 because of the rule in the box. So when you have this equation, you'd subtract 2 to get the value of x, which is 8. The next equation says that 3x is equal to 15. So now we really need to understand what on earth that means. 3x means 3 lots of x, or 3 times x. X could be anything. Just remember, at the end of the day, it's a placeholder. It means 3 lots of something. Now, this question should get you to see from another perspective. You can write 2 times 3, which we know is 6, as being equal to 3 times 2. And guess what? 3 times 2 is also equal to 6. This is just another property of numbers and is called commutativity. However, you don't need to really know what the terminology here is. Using this logic, we can say that 3 times x from earlier is equal to x times 3. And now it's more obvious that in order to get x on its own, we'll have to do something with the 3. The opposite of times, which is multiplication, is divide. So we need to divide by 3. And so 15 divided by 3 gives us 5. Watch back slowly if that doesn't make sense. All it takes is that moment where you suddenly just grasp it. And if the concept of 3x was confusing, put 5 into that equation where x is equal to 5, and you'll see that 3 times 5 gives us 15, which was what we had at the beginning. That's the introductory part done. From here, it's more about applying what you know. It's going to be a lot more harder than those previous examples, so be sure to fully understand the process before you go on. 4x plus 4 equals 24. Again, we just want x, which is just a placeholder. We can see that x is being multiplied by 4, and we are adding 4 onto it, in that order. What I just said, we are going to do the opposite. It's a bit like unwinding a knot, as you'll have to start with the outside of the knot and go further inwards. And for us, it's a bit like that, but we're trying to get to x. However, in order to do that, we need to remove anything that isn't attached to x first. So, using our inverse rules, we'll subtract 4 to eliminate the 4. Remember to do this to both sides. So now you should get that 4x is equal to 20. Now what? I'll give you a minute to have a think. We can write 4x as 4 times x. This isn't what you've shown the exam, since this is explanatory, so you can just skip it. Since they are multiplying by each other, specifically by 4, I'll divide by 4. And 20 divided by 4 gives me that x is 5. Again, just a coincidence by the way, it won't always be 5. Let's take it a step further. We'll introduce 2 variables here, and we want to rearrange for y. So you'll need to keep in mind you aren't going to have a plain number as your answer. It will involve other variables too. You'll need to get comfortable with this concept. This goes for GCSE maths as well. Once you break down that mental barrier, the questions become a lot more smooth flowing. So x is equal to y over 4. We want y on its own. On the right hand side of the equation, we have y over 4, written like a fraction. This just means y divided by 4. So now we know what it literally means. We can apply our inverse rules as normal. We'll multiply both sides by 4 to obtain y on its own. Is equal to 4x. Now we can add some more context to the equation. Given the value of x is 7, find the value of y. Now, as you become more familiar, this is simply just plug and go. So if y is equal to 4x, which is 4 lots of 7, if x is 7, then our final answer for y is 28. So here's the original equation. X is equal to y over 4. I'll admit, this isn't just some random bunch of letters I chose. This is the equation for the mean. The mean is equal to the sum of all values divided by the number of values. I originally did this with just letters because it makes it less messy to teach. However, at the core, the same idea applies. If we bring the equations on their own, they directly link to each other. The y is the same as the sum of all the values, and we can just rearrange for the sum of all values, just the same as we did for y, by multiplying whatever is the denominator. So the sum of all values is equal to the mean multiplied by the number of values. You can see here that nothing changes. We literally just treat the words as if they were letters and manipulate them just the same. This one's for you to do. Take your time and apply the rules. If you don't overcomplicate it, there's not much that can go wrong. We need to deal with the 3 first, so we're going to subtract it since it's adding to the x term. Now that we have the x and just the x, we need to remove that 5. If it's written as a fraction, this is the same as dividing. So here we have x divided by 5. We'll need to do the opposite, so you should find that you need to multiply by 5. As a result, your final answer should be 20. One more thing, I can only stress so much that practice is all you need. I've supplied the content, but if you only do one question, you can't expect yourself to remember it in the exam 2 months later when you're under pressure. Thanks for watching. With the exams coming less than 3 months away, I'd appreciate if you could like the video and recommend it to others studying the course. If I can gain more traction, I'll be able to pump out a few more videos before your exams in June.